Professor Luis here. Today we're going to talk about the sliding filament theory. Okay, so first it begins with a motor neuron that carries action potential to the muscle. Sliding over. As I can't say this good, excuse me. Acetylcholine is released and binds to the sarcolemma. Sarcolemma ion channels open and sodium ions flow through. This creates an imbalance, or imbalance. Then it generates action potential. Again, I can't say it good. Acetylcholine is broken down by an enzyme. And then calcium is released and moved towards the sarcomere. Now, Professor Ernst is going to take it away.
Alright, so I'm going to start off where Luis left off. And I'm going to start up here. So this is called a sarcomere. And it's composed of two different kind of filaments. And the blue one right here on both sides is called actin, and that's the thinner filament. And the thicker one in the middle, in the red, is called myosin. And this whole complex forms the sarcomere. And the Z line right here, this is a Z line right here, and this is what connects the sarcomeres. And so, in this little box right here is what's zoomed in this bigger box. And so the blue right here is the actin, and this is the myosin. And the purple line right here is the troponin and tropomyosin protein complex. And the tropomyosin protein complex is the purple line that's connected to the actin. And the green dots that you see right here is the troponin. And so right now, the myosin heads are unable to bind to the actin because the tropomyosin is blocking the binding sites. And so where Luis left off with the calcium being released, the calcium ends up here. And what it does is it moves over to the tropomyosin and it binds on right here. And what this does is it causes a change in the shape or in the form of the tropomyosin protein complex. And what happens is the troponin removes parts, uncovers parts of the binding sites for the myosin heads. And so when the binding sites are uncovered, it allows the myosin heads to bind to the actin.
So, as the myosin heads try to bind to the actin, the ATP comes in and binds to the myosin heads instead. The ATP releases the energy for this bind, which is known as a cross-bridge bind. This binding is actually the muscle contracting. As the calcium flows in, the ATP binds to the myosin heads, and as the actins move in, the myosin heads move down the line, going in this direction. Then this continues until the signal from the brain stops, and this causes the calcium to stop moving in, which then causes the ATP to stop moving in. Then the muscle contracts and the relaxation period begins.